All right, back with part 2. So we've got our new system. It's example number 3 on your note sheet. I'm not sure exactly which one I want to get variables by themselves. I have y with a 2 in front of it, x with a 3 in front of it. The bottom equation has bigger numbers. I think I'm going to stick with the first one for step 1. So step 1 for solving a linear system using substitution is pick one of the equations and get either x or y by itself. I think y is going to be the best one in this case. So I'm going to make the y the green because it's the one I want to get by itself. All I got to do is divide by 2. So y equals 3 over 2x. So I don't know, if you want to, you can call it 1.5. I'm just going to keep it as 3 over 2x though. 3 over 2x plus 1. This is the expression I'm plugging into the second equation. And that's step 2. Take my second equation, 20 equals 15x minus 10y, and then ask myself, what did I get by itself in the previous equation? I got the y by itself. It's the green y. Okay? And then I ask myself, well, what's the expression y? In this context, it's 3x plus 1. So that's the thing where I put the parentheses in place of the y, and it's 3x plus 3 halves x plus 1. My apologies. I'm really struggling to talk today, even more so than usual. All right, so we take 20 equals 15x minus, so you take 10 times 3 halves. All right, you can plug that into your calculator, but if you know how to multiply fractions times whole numbers, it's just 10 times 3, which is 30, okay? I'll do the calculation up in the corner there. Divided by 1 times 2. So 30 divided by 2 is 15, and it had an x on it, so it's minus 15x. Okay, hopefully that makes sense. And then you take a minus 10 times positive 1. On the next line, you've got 15x minus 15x. In the previous video, we saw that something like 15x minus 15x is completely obliterated. It's 0x, which means there's nothing there, which means absence of numbers. That's what that is. An absence of number. Okay, so then you can just kind of cross that expression out, and you're left with 20 equals 0 minus 10. We've got our second special case here. 20 does not equal negative 10. 20 does not equal negative 10. That's a false statement. When you drop the x's, okay? When the x's cancel, and you're left not with a true statement, with a false statement, like 20 equals negative 10, not true, then there are no solutions. Yeah. They were parallel lines to begin with. And if you want to investigate that a little bit further, think about what the second equation was. The second equation was 20 equals 15x minus 10y. If I were to get y by itself in that equation, I'd subtract 15x from both sides. Negative 15x plus 20 would equal negative 10y. You divide everything by the number in front of y. Negative 15 over negative 10 is a positive. 15 over 10, divide the top by 5, the bottom by 5, you get 3 halves. Okay, you get 3 halves x minus 2 equals y. Sorry. The slope is the same, but the starting points are different. No solution. All right. I got one more example for you. Let's check it out. All right, x equals 5 minus y, 3y equals 3x plus 1. So this one seems to be done for us. Step number 1, done. So this is kind of like, hey, I got the green equation ready to go. Where are we plugging it into? It's 3y equals 3x plus 1. The x was by itself, which means that's a green x, which is the same as 5 minus y. It was an x, but it's actually the green x. Distribute the 3 to the 5, that's 15. Distribute the 3 to the minus y, which is negative 3y, and you get plus 1 over here. The 3y is still 3y on the left. Now I wanted to highlight this particular example because I know it's kind of like you guys are looking for shortcuts all the time, and that's fine. But I think you guys see a 3y over here and a 3y over here and just assume that they're going to cancel right away. They do not. Because if you are minusing 3y here, to move it to the other side, you have to do the opposite operation. To move it to the other side of this equal sign. That's 6y. It did not cancel itself out. 6y equals 15 plus 1, 16. All right, we're going to get a solution here. Divide by 6, divide by 6. Y equals, you can cut that in half, 8 over 3. And it's a messy solution, but still, it's a solution. So then we can move forward with this by saying, step 3, take the result of step 2, y equals 8/3, and plug it into our convenient equation. 5 minus y. 5 minus y is 5 minus 8/3. And there's a couple different ways you can approach this. A lot of times students will just put the 5 over 1, like so. And then find common denominators. So 3 would be the appropriate one to use for both of them. The right's already 8. You'd have to multiply the left times 3 on top and bottom. That'd be 15/3. And then 15 minus 8 over 3, 7. You got your second solution here. So when making a conclusion, This is kind of tricky because, one, you see the same variable value on both sides. One's positive, one's negative. It's not a special case. It becomes an actual numerical value. You get a number answer. The second thing students tend to want to do is that if they see decimals or fractions, they're like, I need to put no solution down. You don't put no solution if you're getting actual number answers. This is just the solution. X is 7/3. Y is 8/3. End of story. All right, I hope you guys found both of these videos helpful. And yeah, thank you for watching. Thank you for patiently going through the videos. Good luck on the homework, and that's all I got.